So in this video, we're actually going to be starting our next topic, and we're going to be looking primarily at electric circuits, which are useful for you guys to know how electricity moves around in wires and how it helps to power our electrical appliances, but we're going to look at it at a much more detailed level. So our first subtopic that we're going to look at is something called potential difference. Now this is really just another word for voltage, which you guys would have heard, and electric current. So we're going to look at these two concepts in particular in a lot more detail. However, first we need to learn some basics. Now, a general overview of this topic. Now, the existence of subatomic particles, so tiny particles, which we'll elaborate on in a minute, are used to explain the charging of objects. And then these ideas are extended to include potential difference in current and describing how energy can be used to separate the charges, and that charges enables an electric current in a closed circuit. And then the measurements of potential difference in current are introduced. So we're going to mainly look at potential difference in current. But as I said, first we need to know some basics about how atoms are structured. Now, the learning intention is that atoms contain positively charged protons and negatively charged electrons. Now this is a table I want you to fill out. So, atoms, everything, you look around you, absolutely everything in the universe is made up of lots of different kinds of atoms. And in particular, well, we're going to look at three subatomic particles. Now, protons, neutrons and electrons. You would have heard about them in year 8 and 9 and 10 science. Now, the first one we'll look at is the proton. So the proton is located in the center of the atom, and we refer to the center of the atom as the nucleus. Now, protons are positively charged, so it's easy to remember. P for proton, P for positively charged. So they're positively charged, and they have a +1 charge, we'll say. Now, mass. Now, protons, one individual atom is absolutely minuscule. Okay? Now, we're going to say that they have a mass number, or a mass of 1 atomic mass unit. Okay, so we're just going to say that they have a mass of 1. Okay? I'll write it AMU, atomic mass unit. But we'll just refer to it as having a mass number of 1. Now, neutrons. Neutrons are also found in the nucleus. Okay? Later on, when we look at radiation, we're going to look at the interactions between protons and neutrons and the stability of a nucleus. And if the ratio between them is wrong, well then things start flying out, and that's when we get radiation. Okay, but we'll look at that in semester 2. Now, a neutron has no charge, okay? Neutrally charged, so no charge. And they also have a mass. They're approximately the same mass as a proton. They're not exactly the same, I won't go why, but for all intents and purposes, we can say they have a mass number of 1. Or 1 atomic mass unit. Now, electrons are our third subatomic particle. And they're whizzing around in electron shells, okay? Now, you might refer to them as electron shells or electron orbits. We're not too worried about electrons in physics. We're more worried about the nucleus. I shouldn't say that. We are worried about electrons, but we're not worried about how they're structured in the shells. That's more looking at chemical reactivity. Now, an electron is negatively charged, so they have -1 charge, and for all intents and purposes they do have a mass, okay, but their mass is negligible in comparison to protons and neutrons. It's about 1/2700th, so yeah, very negligible, essentially 0. Now, our next learning intention is that two like charges exert repulsive forces on each other, whereas two opposite charges exert attractive forces. Okay, so if you imagine, it's just like a magnet. You have the north and south pole of magnets. They're attracted to one another. However, if you have two norths facing each other, they're going to repel. Two souths, they're going to repel. Just like positive and negative charges. Two positives will repel, two negatives will repel, a positive and a negative will attract one another. They're going to apply an attractive force. So charge is basically just the electrical property to which attraction and repulsion of protons and electrons is attributed. So charge is actually measured in a special unit called Coulomb, which has a capital C. So charge is measured in coulombs. And one electron has an absolutely minuscule amount of charge. So it has 1.6 times 10 to the minus 19 coulombs. Now, we often have like thousands, hundreds of thousands, or millions of electrons to even get some charge, like a decent amount of charge. Okay, so one electron has a minuscule amount of charge. It's tiny. This will be on your formula sheet. And 1 coulomb is huge. Okay, it is a lot of charge. So the number of electrons which makes a charge of 1 coulomb. Okay, so if we have 1 coulomb and we divide it by 1.6 times 10 to the negative 19, we're actually going to get 6 times 10 to the 18 electrons. So a crazy amount of electrons just to make up 1 coulomb of charge. So the main takeaways from this is that like charges repel, so a positive and a positive repels, a negative and a negative repels, and unlike charges, so a positive and a negative will attract. Now a positive charge, something I didn't write here but I will mention, is that a positive charge will be attracted to something that is neutrally charged, okay? Because they are unlike charges. Same with a negative to a neutrally charged object. So likewise, this diagram, positive charges are going to exert repulsive forces away from one another, two negatives, repulsive forces away from one another, positive and negative will apply attractive forces, okay? So opposite charges exert attractive forces, or forces of attraction. Now, the forces that they apply on one another are equal and opposite in magnitude, so in size, but they're opposite in direction. So equal and opposite forces. Equal and opposite forces of repulsion, equal and opposite forces of attraction. Now, if you do physics at stage 2 level, you're going to look at quantifying the force between two charges. So this is called Coulomb's law. Now we won't do it this semester, but if you do stage 2 physics, we will look at it. And basically, depending on the size of the charges, the force between them is directly proportional to the product of the two charges, and it's inversely proportional to the distance between the two charges. But that is stage 2 level physics. Now, the next thing that we need to look at is that objects become charged when electrons are transferred from one object to another or redistributed on one object. So, protons and neutrons don't move. They are stuck together with basically the strongest force known in the universe. So it's called the strong nuclear force. So protons and neutrons are attracted to each other by the strong nuclear force. So they don't move, generally. Now, electrons are much more free to move. Now, the ones in the middle orbits, okay, they're happy, okay? They're structurally, chemically stable. However, these outer shell electrons, we refer to them as valence electrons, okay? And these ones are more, they're looking to be, this outer shell is looking to be stable. So it's free to readily accept electrons and to transfer electrons to other objects in order to try and become stable. Okay, so in this case it's neutrally charged because it has an equal amount of protons. So the carbon atom has 6 protons and has 6 neutrons as well, but it also has 6 electrons, so it's neutrally stable. 6 positive charges, so plus 6, and negative 6, because 6 electrons. So overall it's a neutrally stable atom. However, it can either gain electrons or lose electrons, okay? Now, yeah, so electrons are the only charged particle that we can add to or remove from a body, and protons are locked into the nucleus, so they cannot be removed. Now, we'll have some examples to follow. So we can actually have positively or negatively charged objects. So if we add electrons to an object, a neutral body, then it's going to have more electrons. So it's going to actually have an excess of negatively charged particles, which means it will have a negative charge. So in this example here, we have a chlorine atom. Now, as I said, this is chemistry, so you don't really need to know this, but if you're doing chemistry, this is good knowledge to have. So atoms want to become, the outer shell electrons want to become stable. So it needs one more electron to be full and stable. So it's actually going to be readily want to accept an electron from a different atom. And if it does, it's now got 18 electrons. So it's going to have a -1 charge overall. Likewise, if electrons are removed, so this is a sodium atom. Now you see that in its outer shell it's only got 1 electron. So it's much easier for it to just lose this electron. And if it loses this electron, it's going to have 1 extra proton. So it's going to have 11, plus 11, and minus 10. So it's going to have a +1 charge overall. So if electrons are removed, then it's going to have a shortage of negatively charged particles, and it's going to be a positively charged atom, or an ion. Now, basically these observations about charging objects can lead us to the following conclusion. So in an isolated system, so the word isolated means free of all external forces, the total charge of the system must remain constant. So charge cannot be created or destroyed, but it can be transferred from one object to another, so just like energy. So the number of electrons that one body gains is exactly the same as the number of electrons lost by the other atom or body. Thus, the total charge in the system between the two bodies is equal, remains constant. So the last thing I want to look at in this video is conductors and insulators. You would have heard these terms before, but you may not have thought about them too much. Now, conductors, generally, well, if you think about it, your understanding, you're probably going to say something that conducts electricity. Okay? So, most conductors are metals. Okay? They have outer shell electrons, so valence electrons, that are very loosely bound. Okay? So if you have lots of, for argument's sake, copper, okay? We have lots and lots and lots of copper atoms, alright, lined up in a row. Now, they have in their outer shell, they have a few loose electrons. So each one of these atoms has a few loose electrons. So what happens is, conductors actually, because they have those free electrons, they have the ability to allow those electrons to flow. Okay? Now, if we apply, I'll just say for now, if we apply some energy to the electrons, okay, and we can start pushing them along towards, let's just say we're pushing them along, well, negative charges are attracted to a positive charge, right? So if we start applying some energy and we push them towards a positive charge, well, they're going to be attracted, they're going to flow. All those outer shell electrons, those valence electrons, are going to want to flow. And that flow of electrons is actually what electricity is. So conductors, so things like metals that have loosely bound electrons, they allow the flow of charge, okay? However, insulators, things like plastics and rubbers, they're so we got our wire, that's the conductor. So insulators, things like rubbers and plastics, okay, their outer shell electrons, their valence electrons, are actually really tightly bound. So they don't have those extra electrons to allow the flow of charge. So that is why we use things like plastics and rubbers in order to insulate wires, because these don't actually allow the flow of charge, so we can actually handle wires, okay, and it's not going to shock us. So insulators do not allow for the flow of charge. So what I need you to do now is to work on first the booklet, okay, do these 4 sections, and then there's a couple questions in the textbook. Thanks. See me if you've got any problems.